Hel- Hello, Michelle. Hello, Christopher. Awesome, awesome. Hello, Cheska. Awesome. I mean, hello, everybody, of course, but special shout out to the three-dimensional people. Good afternoon, Avani. Special shout out to the verbal. Good afternoon, Hayu. Wait, and there's someone I miss. I see. Oh, and good afternoon, Avani. Oh, a double for Avani. She's like videoing and chatting. Oh, sorry, I missed you, Matthew. Good afternoon, Matthew. Good afternoon, Yavi. Good afternoon, Yeyun. Awesome, awesome. Who else do we have? Okay, we're in a slightly better. Oh, you can hear me, right? Well, yes, because you can hear me. Yes, thank you, Avani. Okay, all right, because you learned it. Ah, interesting. Wait, you learned physics and calculus. Good. I mean, I'm looking at the chat. Good, Christopher. I want to hear about. You know, it's odd. To, wait, are you in? Oh, graph. Awesome. Well, well, don't get me started. That's awesome. I actually would like a good afternoon, Melita. Okay, awesome. You have my attention, Chris, for sure. I'm not sure that could easily be a rabbit hole for me. I could like talk about that all day accidentally, and I'm sure everybody else would not be pleased. I maybe send me a text or something or tell me. Well, okay. I know I can't resist. Just for a second. Is this Calc
It's
2? So Calc 3. Oh, you're in it also, Cheska? Did you just indicate? Wait, you're in the same? And sorry, so I saw your fingers, but I didn't count. It was Calc 3 or it's Calc 2? Two.
okay.
Okay, awesome. With graph. Awesome. Okay, I guess I can. Can you give either both of you or one of you? And I love, I mean, I know graph, he's very traditional, some people don't know how to relate to him. I understand that or whatever, but like, I hope it's clear that you can see that, boy, does he know his stuff. And quick aside about Professor Graff, by the way, who I used to interact with a lot, like way before COVID. We used to talk and work on stuff. Obviously, he's a very scholarly guy, a very intelligent guy. But one quick thing, where he went, oh, this is so not interesting. Where he went to college a million years ago, is the institution where like the physics textbook that's technically recommended for this class, even though we like never use it anymore, but the only textbook I still really believe in for all this material and everything came out of RPI, where he went to school, and he had um, David Halliday. He had as a Professor Graff had as a professor one of the three guys that like wrote our book. Um, I mean, so Professor Graff, he's the real deal, no question about it. But I guess I'm just, did I say good afternoon, Melina? Okay, we have to get rolling, obviously, but maybe, yeah, maybe send me a text. I'm afraid I'm going to be so excited. I'm so excited about any crossover between calc and physics. I really am. I'm just, the reason I don't want to hear about it now is because I won't find the off switch on me. But if one of you two or whoever else is in that class, if you want to send me a text or something, just like briefly telling me what it is that came up in that class, I really would be interested, and it probably would help me teach this class if I knew on the side something that you heard. And to everybody, especially when we get to Physics 204, which is like this is the ramp up to, I will tell you that especially Physics 204 is the place that demonstrates, in my judgment, how for some people, sure, it's good to have some calculus under their belt in order to do physics. But for a lot of people, it's good to have physics under their belt in order to finally understand calculus. Like it can go both ways, which is why we allow them as co-requisites and all that. Like some people learn the physics better if they've seen the calc first, but a lot of people finally understand calculus once they've seen it in physics. And the ideal is that they both keep talking to each other. Like honestly, and for me, I feel like I love them both now at this stage of my life, of course, but it took me a while to get there, and it's because I had to keep going back and forth. It was not like either one of them just made sense the first time I saw it, just for what it's worth. So I love hearing about any crossover. Oh, it was about, okay. Okay, I'm looking at the direct chat. Thank you. Oh, cool. Awesome. Was it an integral? Sorry. Okay, see, I'm going to do this. I'm so bad. You should text me. I don't mean like really, or email me. I don't mean it weirdly, but like, was it a dot? Was it a good afternoon? Okay, I'll leave it alone. But all right, you have my attention for sure. And thank you, direct chat person. Thank you both for, okay. See you. Okay. I'm gonna shut up. No, I'm not. Yes, I am. Okay. All right. So I know we have to make some tracks. I know it's like such a, the way the year starts is like so choppy and everything, and I'm so choppy. What I want to do today, the technology is a little bit better now than it was last Wednesday. The recording did come through for your class last Wednesday. I don't know how good a recording is, but it's been on YouTube for a while, but somehow it didn't make it to your classroom until like just now, but it's in your classroom now. I still owe you grades. Like if you I hope you're getting used to this system. Like if you, on homework three, average speed, which was out of 35 points or something like that, or something. If you got a score that was less than perfect, please again know that's an acknowledgement that you're on time and you're good. And the rest of the points are coming when I scrutinize it more further. It's just to let you know we're in dialogue. I see your work, but I haven't, but I owe you more points. So don't take it, if it's not a perfect score yet, but it is a score, it doesn't mean you owe me anything or you should worry yet at all. It means I owe you something. That's number one. Also on train of thought, train of thought, believe me, we're going to discuss in detail. It's meant to prompt discussion. It's a very, I know I've said this before, it's a very like off to the left side kind of homework. So if you did it on time and you turned it in, I glanced at it, I looked, I know what the common responses were. Like I use it to see what are people commonly saying, what do people commonly think. I use it so I can cater our class discussion around that. So even if I didn't put any marks on it, which I probably didn't because it's like takes a really long time, I looked at it, and if you did it at all, if you tried, if you put answers, think of it as more of a survey, if you like. So you got the full credit. If you did it and you did it on time. If you did it late, you didn't get all the credit yet. But if you did it late, that means I'll scrutinize it more carefully. And that's the consequence of being late. And then if it's still like totally fine, I'll give you all the rest of the points. But if I feel like that was not only late, but that was kind of thin, then I'll let you know. Okay, so train of thought is meant for us to discuss. It was like a survey. So if you got all the points, good, awesome. I'm sorry, there's not more specific feedback. Now, wait, so that's it. And then homework 4, which of course was not due today. It's in theory due Wednesday. I'm well aware, in theory, any information you need to do homework 4, you should be able to do. Any information you need to do homework 4, you should be able to find in the sheet. In theory, it builds off anything we've been doing so far, but it is a big leap. Without a doubt, the leap from homework 3 to homework 4 is a big leap, and it's where the class really starts being a traditional physics class. That's just to say, I'm very aware that you may, if you haven't started homework 4 yet, you may feel very nervous when you take it out. You might feel uncomfortable or even angry trying to do it for Wednesday. I'm telling you right now, don't be angry at yourself. Don't be angry at me. It is understood that it's a big leap. We want to get better and better at making bigger and bigger leaps. You can use whatever resources you want to do it. Blah, 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 blah. Try, but know that I know that it's a big leap, and know also you're going to get a break after homework 4 until I really start talking about it, until I catch up to myself and to you guys. You're not going to get another assignment until I start dealing with homework 4. So I understand it's a big leap. I still want you to try your best. And I also I really want some of you who haven't looked at it yet, I want you to recognize that when you first take it out and look at it, even the title, some of you may say like, I have no idea. Well, how could he possibly expect me to do this? Know that I know that, and know that you're not missing something, and I'm not trying to be unfair or harsh, but know that if you trust yourself a little bit, and you trust me a little bit, and you're willing to poke around on the web a little bit, if you go question by question, don't look at the whole thing as one big project. Think of it as a series of mini tasks. If you go step by step, you'll be surprised. I think many of you to find out that a lot more of it is more doable bit by bit than it looks at first. And we're trying to get you, that's the deal with physics. So this is to say 2 things at the same time. 1, I'm totally sympathetic if you find homework 4 a big leap. You're not crazy if you do. But 2, I still want you to try it anyway and see how far you can get and do your best job for Wednesday. And like always, first I'm just going to see who did a thorough job, who tried. I'll give a bunch of points for that. Then we'll scrutinize it further, and you'll have time to add more and revise more when we start talking about it. Okay, so it's all part of the system of us getting more and more used to literally trying to figure out things on our own, because that's really what physics is about. Okay, so that's to say both things. Don't freak, but do try. Okay, that's about homework 4. Oh, sorry, so I'm looking at the chat. No problem. Thank you for the direct chat. I see. I got it. No problem. No problem. And also, if I'm totally off, let me know. But I think that's our deal. Now I know believe me, I know we're only on homework 1 now. I'm well aware. We have to start making tracks. Well aware. It happens like this every semester. And again, the whole theory here is the more everybody really knows how to do the fundamentals, the more you use the fundamentals to do the things we don't know how to do. So we spend a lot of time on fundamentals. Anyway, so what I'm going to do now, with your permission, and stop me at any moment to go slower or faster in the chat. And I also still owe you a lot of the game portals. I know there's game portals like video and stuff that you guys have submitted that I still haven't gotten back because I fell behind, but I see them and you will get them. And just keep re-uploading them and blah, blah, blah. What I need to do today, what I'm going to do today, is finish going over homework 1. Then, and homework 2, as you know, is like shorter. So then we'll start to make a lot more fast progress. We're going to finish homework 1 today in the effort. Yeah, in the effort. Yeah, and in the effort to finish homework 1 today, once I get rolling, I'm going to assume, and you stop me in the chat if this assumption falls apart for you. I'm going to assume now we really spelled out the 5-step method. I very much did look very carefully at your homework once to see if you really were doing the 5-step method, and if you weren't, like you did it again, blah, 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 or you still can. So today, I'm not going to drag out the 5-step method quite as in detail as I did last time. I'm going to try to more just get to answers when I think I can just get to direct answers for you, or if I think there's work that is unobvious, I'll do the non-obvious work. But I want to just warn you that whatever notes we take today or whatever I do on the screen today is more like it is me just talking to you and giving you what I think you need. So if this were an exam, right, or if this problem were on an exam and then you went to do the exam, you wouldn't just copy directly what I said right here and then expect full credit for it. Like, I'm not doing the full 5-step method because I'm assuming you get it at this point. And if that's confusing, let me know. But okay, I'm just going to try to make tracks. Last thing, and I'll talk about, but I'm not going to write out step 1 every single time, and I'm not going to write out the diagram every single time. Last thing, this equation that you keep seeing on the freaking screen, which I know is starting to bore you to tears, is probably really annoying you that you keep seeing one equation. But I want to emphasize, as far as I'm concerned, this is the only equation that we have so far. It is. It's the one equation we have so far. Now, and we're gonna get more, of course, but part of the whole thrust, well, we'll see as we're going through, the thrust is physics is not about some long list of formulas that you're supposed to memorize. It may have felt that way in high school, but it's not what it's supposed to be about at this stage. Every equation is supposed to come from something that actually makes sense, either in English or as a definition or blah, blah, blah. So right now, if this is the only equation we have, what that does mean is supposedly anything that we would need to figure out, even if it's hard, anything that we would need to figure out should be able to be figure-outable from this, certainly all through homework 3. Homework 4, it starts giving you new equations. I know that. But nothing, everything should boil down to this logic right now. And that's how, and this equation, we believe, because it's a definition, right? It's not a discovery. So this is all we know right now. And that's good and bad, I suppose, but it's the case. Okay. So I'm going to get going. I'm also, did I already, you can hear me, right? Yeah, I already answered. Okay, so there's, and hello, hi, yeah, okay, great. Okay, so here we go. So stop. So we're going to homework 1, number line. I'm going to change the screen view. Okay, I'm just changing the screen. And also, this got confusing in the other class. I'm on, as far as I know, we're still in homework 1. We're going to blast through it today. It's answers. It's not the full format of 5-step solutions all the time. But I think that we're still in part 1 of, stop me if I'm wrong, but I believe, I'm going to pick up, I think we're on question 4 of part. So please tell me if the chat if that's not right, but I think we're in part 1, question 4. Is that, do I get confirmation? Sorry, I should take, can someone just, literally in chat, because I just closed a certain screen, can you just confirm in chat if that is basically your impression, part 1, question 4? Is that, oh yeah, okay, thank you, Christopher. Okay, I couldn't see faces for the moment, but thank you, Chris. Oh, thank you, Avani. Okay, great. All right, back to, okay, so here we go. So question 4, just assume, so here, see, I keep defending, but C diagram above. All right, so if I were doing the flat step method, I would write C diagram above, assume you already have the diagram in front of you. That's my step one. Then step two, I write down the question, right? From t equals 0 to t equals 8, what does V bar equal? So we're now into like some physics that actually has notation and actually has like equations, right? So it's actually asking what's the average velocity from t equals 0 to t equals 8. Now, side note about notation that we established last time. From here on in, V, the letter V stands for velocity, okay? There's more than one kind of velocity in physics. It's like a big issue in physics. The only kind we know right now, though, the only kind of velocity that we're learning is a special kind of velocity called average velocity. So we put a bar over it, right? Like, don't think that that you've missed something, that we're already up to average velocity and you missed regular velocity. You didn't. We're talking, the first thing that we're defining in physics is average velocity. So we put a bar over the V. And from now on, notation wise, if I didn't say this last time, anytime we have any symbol, any variable, call it a squiggle, like squiggle just stands for like any variable at all. If we put a bar over that squiggle, that means the average value of that squiggle from now on. Okay, so like A with a bar over it would mean average acceleration, etc. Now notice this. This is kind of an important thing, a subtle thing. Is that whenever we have the average, whenever we have a value at all without a bar over it, even if we haven't defined that yet, if we have just squiggle, that means we want the value or the measurement of squiggle at a single point in time or time and space, right? So like V without a bar over it, even though we haven't defined that yet, and we don't have an equation for it yet, but V without a bar over it would mean the value of velocity at some moment, at some position. Now, we mentioned last time, that's a very precise idea. Like, how fast are you going, like right now, right? You might think we would have started with that idea because it's so precise. But that's a much harder thing to measure or even to picture in our minds. You'll see if you haven't already thought about that in high school. So in fact, so what we have started with instead is we're starting with the definition of the average value of velocity. And it turns out that whenever we do an average, one of the reasons that averages are less accurate or less precise, but more measurable and more picturable, averages are, because averages, I'm just reminding you, I'm telling you, an average value of anything is the best representative value of that variable in application to or throughout an interval or a segment or a region between 2 points in space and time. This is a subtle but very important distinction. Just like in physics, we distinguish between double equal signs and triple equal signs. In physics, we distinguish between values at a point versus values that apply over an interval between 2 points. An average value is easier to measure, easier to picture, but it's less accurate. It's the one number that represents an interval, and generally, so what I'm saying now, and I will move on. As far as I'm concerned from here on in, when I hear the word average in math class or physics class, to me, what average means is the one value that represents a whole list of values or a whole set of values in a context where those values might well be changing a lot. They might be changing in a pattern. They might not be changing in a pattern. If you have a whole bunch of values that are all different, the one value that you could pick that would best allow you to pretend that there was no change is what we mean by an average. Put another way, if you're taking notes, which would be great, what an average really is the most truthful lie that we can make about a set of values, right? It's the least false value that we could pick if we wanted to represent a whole bunch of values with just one. That's what an average is. Why am I yelling about this? Because I'm a yeller. Why am I yelling about this? Because what you'll notice is that's the concept of an average. One number that represents a whole. It's by its nature, it's not necessary, it's accurate only if you understand what it's trying to do. It doesn't capture all the information. It represents a bunch of information. That's what an average is. But when you get into things like to get an average, we add up. If you ever want the average of 7 values, you add up the 7 values and divide by 7. Well, that's one way of calculating one type of average. That would be called an arithmetic mean, right? Adding them up and dividing by the number of things. That's totally, I'm not saying it's wrong, but it's one way. You know, there's also a mode, such thing as a mode average. There's also a such thing as a median average. There's also a such thing as a geometric mean. So what I'm just trying to establish right now is from here on in, whenever you hear the term average in science, don't immediately make any assumption about how that average was computed. Just make the assumption that what the average means is it's one value meant to represent a whole set of potentially changing values, okay? So the average velocity, we said last time, I believe we said right at the end of last time, and all what I'm talking about right now, you know, is kind of like a teaching sidebar, or you could say this is all about the step 3 GDP for this problem, right? The problem is question 4, what is the average velocity from this moment to that moment? So the GDP, like, is right here at the top of the page, the step 3. But it's the only, and it's really the only GDP really we have so far in this class, really. So I'm expanding on it a bit to show you how powerful and how subtle it is. This GDP, average velocity, is defined to be displacement per time. Please note, like the way it's set up, it's just like, it's like change in position divided by change in moment. It's the most simple, straightforward ratio that we could construct between a chunk of space that you traverse versus a chunk of time that you endure. Right? It's like literally like, what do we take, a chunk of space that someone traveled, and we divide it by the chunk of time that it took them. We're giving equal weight to both factors, the space and the time. We're not squaring one, we're not square rooting the other or something. So we're just defining from now on that simple standard ratio of space per time is from now on going to be called average velocity. The top of the fraction looks totally like the bottom, like we're treating both the same. But then there's that notational subtlety from last time that says, well, whenever you write T naught, you don't really have to write it because T naught is always 0, even though X naught is not always 0. T naught is. So we tend to leave it out. So we tend to write it like the GDP, we tend to write like this way, but I just want to emphasize to you, that's like our shorthand of writing it. We're really just from now on saying what average velocity is. Okay, last thing, I know I'm over talking this. I've met myself, I'm over talking this, but I'm really trying to warn you all and prep you all for whatever you did on the average speed homework or homework 3. Like, I'm really trying to drum in why the last 2 questions might have tripped some people up. Because what I'm saying here is all I know about average velocity right now is it's the total displacement for the total time. What I don't know, and that represent, like, if you traveled 60 miles in 2 hours, then on average, you were traveling 30 miles per hour. That's what we're saying, right? We're not saying that you were traveling 30 miles an hour here or here or here necessarily. Like, you might have been who knows what you were doing. But on average, you were going 30 miles per hour if you travel 60 miles in 2 hours. On average, you were traveling 30 miles per hour. And what does that really mean to say that? If I say a truck went 60 miles in 2 hours, and then a physicist is like, oh, well, on average, the truck was going 30 miles per hour. What does that really mean? It means that truck accomplished the same, that even though that truck might have been changing its speed and velocity all over the place, it accomplished the same thing as a truck that went at a constant velocity of 30 miles per hour for an hour. You see what I'm saying? Like that, if you had to pick one number to just pretend everything was constant, that's what the number's 30. That's what we mean by the average. So anything else is not our definition. You're not saying that the definition of average velocity is like add up a bunch of velocities and divide by 7 or something. We're not saying that. That's what I'm really trying to emphasize. All right. This is the one thing we're saying, the one thing we know. It's always true. If you had to take an exam right now and I asked you any kind of question about anything, the first GDP you'd write down would be this, even if you didn't know what to do with it, because it's like literally all we know. That's always true right now. And even if you didn't know what to do with it, you'd get points because it's true. Okay, blah, blah. So here, to go with this, so that was my GDP. My GDP, my step 3 is average velocity is defined to be displacement per time. Now, step 4. PAW, what do? I say here, in this case, x minus x naught, the displacement is -9 feet. Let me be, actually, I can be slightly more specific about that. I specifically mean that here, in this case of this problem, x minus x naught is -4 5, right, minus positive 4, which equals negative, right? Because the final position where the guy ended up, after the whole journey, was at the -5 mark, according to the fact pattern, and where he started was at positive 4. So that's his displacement. You could almost say from now on that's a GDP. Like, displacement is x minus x naught. The total time for the whole thing was given as 8 seconds. So boom. So the answer for question 4 is the average. In fact, let me just add. So the original question was, from t equals 0 to t equals 8, what is v bar? The answer is, well, from t equals 0 to t equals 8, v bar equals -9 feet per 8 seconds. Or if you like, I mean, sure, it's like maybe a little better, right? Like -1.125 feet per second. So write it either way you want for something like this. And notice your final answer refers back to your original question, but now it's a double equal sign. We're not saying this is, we are saying this is an equation. We're not saying it's a definition. We're not saying it's a law. We're not saying it's true for all time. We're just saying we discovered here in this case, given these facts, that the average velocity for this situation was -1.125 seconds. Okay, that's the answer to that one. I'm going to start going a little bit faster. But now notice also, now that we're starting to get into physics, notice our answer is negative. Just like displacements can be negative, velocities can be negative. That it doesn't mean Michael J. Fox. It doesn't mean a flux capacitor. Like, a negative velocity doesn't mean we're going back in time. And it also doesn't mean we're slowing down. Just please note that. It just means we're going at that rate, but in this direction rather than that direction, right? That's all it means. It means that the instructor on average travels that way at 9/8 feet per second rather than the other way. So velocities can be negative. Okay. All right. So that's, you can stop me. I'm just looking to, is there any, are we cool? I'm going to go on. I'm going on. Again, I'm speaking fast now because I think most of you want me to ramp up. But it's not to rush you. If you have an issue, please let me know. I'm serious. But other than that, I'm going to keep going. Question 5. So now question 5. Now notice question 5 goes back to average speed. It's almost annoying. Like, we feel like we're getting somewhere, and then it's like, and notice when it goes back to average speed, I go back to English. Again, these vector quantities like velocity and displacement, they're the ones we really ultimately care about in physics generally. They're built up from the sort of more primitive notions of speed and distance. So whenever I'm in the more primitive notions, I tend to stay in English. And then when we're up to the vector quantities, I tend to use equations and symbols. And believe me, we're going to be in a lot of equations and symbols very soon. But I like to go back to the English occasionally just to keep reminding you, all of this stuff should be coming down to logic and common sense and language that you can picture in your brain. None of this should just be something that we memorize just because we were told. It's supposed to all make sense, ultimately. So it's asking for the average speed. Some people in the other section were like, wait, didn't we already get this question? Weren't we already asked this? Yes and no. In question 3 or something, question 3, we were asked what's the average speed for the whole thing of t equals 0 to t equals 8. Now it's asking you just from t equals 0 to t equals 5. Okay, same GDP, average speed is defined, triple equal sign, to be distance over time. Then here, I've switched it to, here, the PAW, the step 4, the distance, the distance is first he traveled 6, and then he traveled 6. First he traveled. Well, I guess technically, I'm so sorry. Hold on. I mean, that's right, but I guess it's really. Yeah, I guess it's really the absolute value of -6, then plus the absolute value of +6, right? I mean, distance is the magnitude of displacement. I'm not gonna overtime. So you can ask me questions if you want, but the bottom line is, we do the same thing we did in question 3. But you notice that because we're looking at a different time interval now, or a different segment of the journey, we get a different answer. And that may be obvious in a way in this question, but it's also like a warning sign or a caution, like, please note, average is for a given interval. So it depends what interval you pick, what answer you get for average. That's really important for the last part of the whole homework. when a lot of people made mistakes by plugging in an average that applied to everything for just one segment. Well, you'll see when we get there, but averages change from segment to segment. So we have to be careful about that. So before we got that the average speed was 21/8. This time we get that it's 12/5, which is 2.4 feet per second. That's the answer to question 5. I'm going to go on unless there's, I'm just going to look, is there any, no, it doesn't look like there's questions. Looks like you're fine. Okay. Okay, you're bored, which means at least it's clear, I think. Okay. I'm bored too. Okay. So now we go to question 6. Now it asks for the average velocity. So now it's back. I'm going to be a little more mathematical about it, but same thing. I won't drag it out. Average velocity is displacement per time. There's my DDP. Displacement is final position minus initial position. The final position, and now notice, please just notice again, we're talking now about this interval. So when we say final position and initial position, we don't mean for the whole freaking experiment, and we don't mean for the whole universe. We mean for the segment that we're interested in for this question. We're asked about t equals 0 to t equals 5. So by initial position, so by final position, we mean the final position at t equals 5, right? So part of what train of thought, which we haven't talked about yet, part of what that's trying to drum in from a different perspective is that we keep deciding on the coordinate system. We keep deciding on the reference frame. We decide where the experiment begins and where it ends. We decide where the experiment begins and where it ends. We choose the perspective from which to measure and analyze the experiment. That's like huge in physics. So we keep resetting our coordinate axes and our origins. Just note that when it's not so bad, because it becomes really important when it is. Okay, so our final position at the t equals 5 is the positive 4 mark, but our initial position also happened to be the positive 4 mark, right? Just if you just read the instructions of the whole problem, that's the fact pattern, that's true. Therefore, the change in position from t equals 0 to t equals 5 is 0, right? So we have 0 in the numerator. I don't care what we have in the denominator, assuming it's not 0. We have 0 over anything equals 0. So we get as the answer for this question, for question 6, we get that the average velocity is 0 feet per second. Now, just like it's perfectly reasonable for an average velocity to be negative, but not an average speed. An average speed can never be negative, but an average velocity can be negative. Well, similarly, a person can do a whole lot of moving, a whole lot of running around, and still have their average velocity for a segment be 0. Just like I can do a lot of talking and not really say anything. You might have noticed. This dude he went like, so if you just put a speedometer or a radar gun, if you're a cop and you put a radar gun to him, you watch, he's in motion, 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 he's in motion. There's almost no point where he's not in motion. He's like always in motion. So if you're just looking at his motion and you don't care about direction, he's on average going a consistent speed. I mean, he has an average speed that's higher than 0. And we found it. It's like 2.4 feet per second. But if you look at his displacement, if you take into account direction, if you really want to ask, how far did he get displaced during this time of 5 seconds? Well, he didn't get anywhere, right? On average, he was not displaced. He started here, he went there, and then he ended up back where he started. So his average velocity. So the average velocity for any round, so just note, I guess if it's not already evident, for any, or maybe it said it in the sheet, but for any round trip, or what we're going to from now on call in physics, for any, we really call this in physics, for any closed path, which means the same thing as a round trip, for any closed path, the average velocity is necessarily 0. Necessarily. You see what I'm saying? Okay, but I think you got that. So that's the answer to that one. Again, stop me if you don't like it. But now we go to part 2. I want to use the equations more and more. I want to use the notation more and more. So I'm now starting to notice a pattern. If displacement is defined to be x minus x naught, then it seems to me for any given interval, I think I'm safe to say from now on that distance is the absolute value of displacement, right? Like for a given interval. So in question 1, when it asks, I forget what in question 1, I think it asks, What is distance? I remember asked in question. Sorry, in question when asked. Oh yeah, what's the distance covered when he goes from x equals -2 to 4? Well, and I admit in advance, by the way, this set of 4 questions that's asked here, they're kind of stupid. I mean, I wrote them a long time ago, but I'm not quite sure what I was getting at. They're kind of so I'll just say you probably didn't have a problem with it. I think the answer to question 1 was the distance is 6 feet. I mean, he moved a total. He went from 4. He went from -2 to 4. So you do 4 minus -2, and you get 6. And then you should take the absolute value of it, but you're taking the absolute value of a positive number anyway because he was going to the right. So it's like not really an interesting distinction. You get 6 as the distance. And then if you go to the next question, question 2, where it asks for the displacement, you don't take the absolute value, but they both are 6 because he's going to the right. If he'd been going to the left, which really would have been a slightly better question, if he had been going to the left, you would have gotten -6 for the displacement, and you would have gotten +6 for the distance. But I think that's clear to all of you because you wouldn't have gotten this far in the homework if you didn't understand. And I'm not being sarcastic. If it's not clear, there's no shame, and you can put it in the chat. But I get the feeling that is okay with most of you. So it was 6 for the distance in question 1. It's, again, 6 for the displacement in question 2. Always have to have our units in our final answers. They're both measured in the same units. Okay. So then we move on to average speed. All right, same deal here. Average speed is distance over time. So you take the distance that you just solved for, and you put it over the time that you were told. The time is the middle 2 seconds. It's 2 seconds. So you put the distance over the time, you get 3 feet per second. Average velocity in question 4, you do the same thing. Again, it might be a slightly more interesting. You're getting the same answer both times because the guy's moving in a positive direction. There's not a major takeaway from these 4 questions. They're a little bit silly, perhaps, but well, I guess yeah. The only other takeaway is like how much does this prepare you for an exam? Well, okay, of course, by the time we get to the exam, the problems are a little bit harder for sure, but they have this structure. Notice one thing about this structure to the problems, and again, I'm sure you've encountered this in other math and science classes. Notice that the questions build, that generally speaking, especially when you get to real things, really the whole point of a big physics problem like this is it really by the end, we figured something out that was maybe interesting and maybe not obvious that we maybe didn't know right from the start. Usually the end of a physics problem is the real thing that we're really trying to discover. And all the parts that come before the end are baby steps, are designed to be steps toward that ending. So what looks tedious, like a whole bunch of questions, often we're asking you questions to guide you to the information that you need to start putting together for the end. Now that's a good thing for you to keep in mind consciously, because like if you get to homework 4, for example, which will be a little bit harder, maybe a lot harder, bear in mind that even there, at least within a given problem, the pieces are meant to be building in an order. It's often very likely if you've just done a question and you sort of got an answer, maybe you're not confident of it, but you got some kind of answer for a question. And then you get to the next question and you think you don't know what to do. The first thing to consider is there any way I can use the information from the thing I just did to do this next? Like that's worth writing down in notes or something. Like if you solve a question and you get an answer, then when you go to the next question, bear in mind that you might well be expected to be building off that last answer. It's probably meant to be helpful to you. Also note, therefore, this stresses people out. If you do question 1, like say, like on homework 4 or on exam, if you do question 1 and you get an answer, but you're not sure of it. So now you're getting a little bit insecure. Now you get to question 2, you're not even sure how to do it at all. You're already insecure about, I mean, I don't know if this happens to not you, me. If I did question 1, I squeaked out an answer, but I'm really not betting $1 million on it, but I got something. Now I go to question 2, and now I'm thinking, well, question 2 is like based on, I bet it's like based on what I just got on question 1. So that's a hint. But then I think to myself, especially if it's in the middle of exam, I think, oh, well, great. Well, that's great news because I'm pretty sure I beefed. That's not a word. I whiffed on question 1. Like, so now I'm supposed to use that information in question 2 and I'm not even confident of it. But no. Do it. Use it anyway. Because we're not going to double jeopardize you. Like, we're going to see in question 2, did you correctly deploy the information you got in question one. If your question one was wrong, we take off points there. But we're not going to double take off. You see what I'm saying? Use the information in the next. If you use it correctly, you get the credit, because that it's about the logic of that. I hope you heard me say that. Wait, I'm just going to pause for a second and just see. Is that, do you get what I'm saying about that? Is that cool? Like, okay, thank you. Okay, awesome. Which is, okay, now since I'm doing this anyway, secret trick to write down. I think that a lot of these things I'm saying are kind of in that sheet under tools that say knowing what to do when you don't know what to do. But it's like there's a lot of brilliance in that sheet, if I do say so. But it's written in a really weird way that you might not ever want to read. I understand that. See, if there's a big takeaway of what I just said that really applies to physics exams and other science exams and future science courses, the big secret of what I just said is, therefore, at all costs, what you always want to just try to do is keep the beat going. Like, I'm going to say this once, as long as I'm saying this, really, it took me 20 years to figure out this insight, but it's such a big trick. Like, really, say you're in the middle of a question on an exam and you have two choice. You're like, I kind of think, well, first, like, I have no idea. People always, well, you probably do. What you probably mean is you have an idea, but you don't think it's right? Or you can't decide between two ideas. You don't know which one's right. Once you can get a question down, if you're like, well, I think I'm supposed to do like a trig thing here. I think I should do like sine or cosine, but I have no idea whether it's supposed to be sine or cosine. Like, and then I'm like frustrated, I'm panicking. I have no idea. How do I freaking know if I'm supposed to do sine or cosine? God darn it, right? And then if you're like me, you start getting frustrated, you freeze out. But here's my point to everybody. If you can even get it to the point where you're like, I kind of think it should be sine or cosine. If you think your big problem in life is you don't know whether to decide between sine or cosine, that is not a big problem in life. You are in much better shape than the person next to you who truly has no idea. If you can get it down to a choice ever in exam, like, I think I don't know if it's sine or cosine, instead of being afraid to be wrong, and instead of just flipping a coin or whatever, if you literally think it's 6 and 1 and a half dozen of the other, like, you literally cannot decide. I don't know if sine is right or cosine is right. You know what you do? You don't try to pick the one that you think is right. Like, literally don't. Like, here's the advice. That's surprising. If you literally can get something down to a choice between two things and you don't know which choice is right, then stop trying to figure out which choice is right. Don't try to figure out which choice is right. Do the choice that will allow you to go on further in the exam, i.e. do the choice that you're more comfortable with, period. If you know that the sine of 0 is 0, do sine. And you don't remember how cosine works, do sine. Just do the thing that allows you to do another thing. That is honestly one of the most important pieces of advice in all of science and going on in this program and on any exam. Don't try to do the right thing when you don't know what it is. Do the thing that allows you to do another thing. Because the more you can just keep going, the more you're passing the most important, hardest test of all of this science program, which is who can keep going and who stops. So just do the thing that I'm dead serious. I'll go on now. I'll keep going. But really, that's how you make choices in the middle of exams. Because again, we don't double jeopardize you. If you put down a number and it's wrong, you picked sine and you were wrong, so you'll lose points there. But now you can base the rest of your thing on that and you'll be fine. You get it. I'm going to go on. Okay. But like, that is the reason that's really important advice is it's actually harder to do than it sounds like. But if you get, anyway. All right. So the next question, average speed. So now it asks what the average speed is from t equals 5 to t equals 8. I'm watching the time. Yeah, we're going to finish this in time. The average speed from t equals 5 to t equals 8. Okay, so again, we're back to English now. And again, it's like the same freaking question that you've already been asked 3 times, but it's trying to drill in your head. Averages change from interval to interval. So the average speed for this interval is the distance over the time. The distance is the absolute value of the displacement. So the absolute value of, so the displacement is actually negative. So we're looking at the last 3 seconds of the journey when he's going like this, all the way from +4 to -5. So the displacement for that last bit is -9. So the distance is the absolute value of that, which is +9. So it's the average speed is +9 feet over 3 seconds. The average speed for that last segment is +3 feet per second. So that's the answer to number 5. So then we go on. Then question 6 is asking the more elegant, more precise thing about average velocity. Same logic, we want displacement over time. So I'm just taking the information I just used back there. I say the displacement is -9, the time is 3. Time is always positive. I don't know if you've noticed that, but that's true. So the average velocity is -9 feet over 3 seconds, so it's -3 feet per second. Now we're almost at some of the interesting questions of this sheet. I'm going to tell you right now, that was tedious, perhaps. It was like maybe like repetitious. But this answer that we just got here, we definitely just got it because we're going to use it to finish off this sheet in part 3 where things get interesting. And I'm going to warn you that where people did make mistakes in part 3. Part 3 is worth talking about. It is not worth being ashamed of if you got it wrong. It's worth talking about if you got it wrong. And even if you got it right, it's worth seeing some techniques that you can practice here if you're not stressed by the question. But this answer that we just got, -3 feet per second, is a piece of information we need to use in the last 2 questions, or one of the last 2 questions of the sheet. And a lot of people didn't use it. So here we go. Yeah, part 3. Part 3. Okay. At part 3, question 1, it says at t equals 7 seconds, at t equals the 7th second, what does x equal? Right? That's the question. At this moment, at 7 o'clock, in effect, what is x? Okay. Now, I'm not saying, again, I know a lot of you got this right, which is awesome, which means but I still want you to please pay attention to how I do this now. A lot of people got it wrong, which is fine. You should not be ashamed. You're still in the right class. But this is now worth talking about. So let me be clear about my steps. I mean, the diagram is above, so that's step 1. And again, I know I'm so, like really at this stage of the game, I'm here to teach you how to learn physics. And so I want to say again, somewhat defensively or apologetically, if you happen to be a person who got this question right or knows they got it right, then instead of using that as a reason not to pay attention at all, I mean, if you need and I'm not looking at anybody right now. I'm not saying anybody's doing that. But as a warning, if you got this right, use it as an opportunity to relax and see if you can absorb a different way of thinking, or see if my way of thinking is different from yours. More specifically, we're about to get into a zone where some of you got the right answer, and you're going to see on your paper that you might have done it a way that might look different. So some of you would very reasonably be saying now, okay, I got the same answer, but I did it a different way. Is that okay, Prof? And in advance, my answer to you is if we get the same answer, but you did it a different way, then it is okay in the sense that I would give you full credit on an exam. Sure, if your way is right, sure. But if you got it right and you did it a different way, then that means you're not stressed about the question. So you should relax and sit back and watch my way. Because now I'm going to say, yeah, you could have done it your way and you could do it your way. But here's the opportunity for you to learn a way that will probably serve you better when the questions get harder. So you're in a better position to learn a new technique now if you're not stressed about and those of you who didn't get the right answer, watch the technique. What the heck am I talking about? I'm talking about this. I'm saying there's step 1, there's step 2, right, is the question, right? That's step 2. Now, step 3, GDP. Right here is where, like if we didn't have this whole 5-step method, this question is asking, where is the instructor at t equals 7? If we didn't have this whole step method, this is where a lot of people, in my past experience, a lot of good citizens, well-meaning people who are smart and who've done science, would look at this question and go, wait, he's asking position? He's never taught us how to get position. Like, wait, he's asking where is he? We've never taught us how to get where is he? Or what's the formula for where is someone? We don't have an equation for where is someone. Like that is all, or something like that is going through, or just someone might be thinking, he's asking, where is he? Like, what? I don't even know. Like, what? That's not a question. Like, we've been told where he is up until now. Like, we've been trying to compute velocities and stuff. What do you mean, where is he? Like, that's not like a fair question. I'm not being sarcastic. I'm not making fun of anybody. But it's very reasonable at this stage for you to look at the question and be like, wait, is that even like a fair question? Like, what? So this is where, and then you might say, I have no idea. I don't know what to do. Or some people would say that, and they wouldn't be criminals for saying it. But here's where I say, well, what we need to do is write a GDP. We need to do a step 3. Like if we think we have no idea, once we've written down the question, we have to start setting up a general truth, a definition or a law, what some of you might call a formula, but I hate that word for reasons you'll soon see. We have to write down something that is true, and then we have to make it relevant. We only have one thing in this class so far that's true. Like really, that's universally reliably true. The only thing we have in this class so far is average velocity is defined to be displacement over time. So that's got to be the thing to write down. I'm not trying to be sarcastic. Like it doesn't look like it answers the question yet because it doesn't solve for position and the question's asking for position, but it's the only thing we know that's true. So even if we don't know yet what we're going to do with it, we write it down. Like I'm going to phrase this one last way, and please put this in your notes, especially if you got this question right. Maybe you don't even know if you got it right or yet or not. Well, I'll end the suspense. Hold on. I think the answer to this question is -2. Okay, just to end the suspense. I'm going to get it. But if you got -2, fine, you're right. But please don't tune out. Tune with me and notice that what we did here, I don't even know where I'm going with this. I don't even know how to solve this. I really don't. I mean, I do, of course. But like at this stage, all I know is I'm writing something down that's true. What I want you to put in your notes, especially if you got this right and you're still with me, what I want you to put in is another observation. When people panic in exams, when people don't know what to do, which is what we're trying to prepare for here by looking at things we do know how to do, when people don't know what to do, when people don't know how to do a question or don't think they understand a question in the exams, what people tend to do unconsciously is they tend to try to write down something relevant and then they try to make it true. Let me repeat that. Please put in your notes. The common misconception, the common panic attack, the common mistake that we all, and this definitely includes me. I mean, I only figured this out because I saw myself doing it so much in college and graduate school, whatever. The common thing to do when we panic or just when we get a little nervous or a little unsure is we think, I better write down something relevant. I better write down something that I think the professor is looking for. I better write down something that I think this question is like supposed to be testing. I better look for what I think we learned or what the professor, I better write down something relevant. And then I'm going to do some algebra or some tweaking in order to make it true. I'm not saying any of you has consciously ever stated that as a strategy, but I am telling you that's what people do unconsciously. They try to write down something relevant and then they try to make it true. And the reason they freeze up and they go, I have no idea what to do, is because they can't figure out what's relevant. Like, because what is relevant here is we need a way of getting position, and you never learned a way to get position. So don't do that. Don't try to write something relevant and then contort it and distort it until you hope that it's true. Because honestly, you can't turn a falsehood into a truth anyway. What we should do, and I'm asking you to put this in your notes, instead of trying to write down something that's relevant and then make it true, when you panic or when you don't know what to do, which again is not, I know a lot of you did not feel that way with this question, but some of you did. If you don't know what to do, write down something true, even if you don't know what you're going to do with it. Write down something true and then work on making it relevant in step 4. Step 3, the only truth we have is average velocity equals displacement over time. So I write it down. I don't even know where I'm going with it, but it's a truth. So I write it down. And honestly, even if I freeze there, if this were an exam, I would get points for having written that down because it's not an error. It's like true. And it's like vaguely on the topic. I mean, it's not like writing, I mean, I wouldn't want to write down P equals nRT or something in the middle of a physics test, but I write down average velocity equals displacement over time because it's true. And I just got points for doing that. Now I go to step 3. I mean, now I'll go to step 4, where I look at the particular application in work. So what do? I start rearranging. I start manipulating the truth in order to make it relevant. What do I mean by relevant? I mean, well, the question wasn't asking about average velocity, which again is why it wouldn't occur to a lot of people to write that down. They'd think, oh crap, I knew what to do when he asked for average velocity because I had a formula for that. But now he's asking me for something else. So no. You see my point. So now in step 4, we start rearranging the truth to make it relevant. We start solving for the thing that's being asked for, which is position, right? But here now too, I know a lot of you who got this right did something like what I'm doing, but let's be honest, a lot of you probably already plugged in the numbers by this time. Like the reason a lot of you, and again, I'm just saying this to be what the reason that a lot of you might still be bored right now, and I sympathize. Like, but those of you are like, dude, I mean, I got this right. I mean, please, can you just go on? I mean, I get it's negative too, but if you did it and you did it, or you just want to know, but is my way acceptable? If your way is that you've already plugged in numbers by this point, you would get full credit if it worked. If it worked, you'd get full credit. But I'm telling you that the harder this stuff gets, and especially when the calculus comes in, and especially when it's physics 204, plugging in the numbers that fast is going to get you into trouble once things get more challenging. So I'm telling you now, those of you who don't know what to do here, I'm telling you what to do. But those of you who think you did know what to do, I'm telling you, use this as an opportunity to look at your own work. If you've already plugged in numbers at this point, okay, it means you're confident. It means you're not stressed out yet. Good. But then use this comfortable zone to try to develop a new habit, which is don't plug in numbers until the last possible minute. Put that in your note. Like I'm saying, for PAW, my really important advice is leave all algebra general as long as possible. And or calculus, whatever the abstract analytical mathematics is. And I'm going to say one last time, I'm telling you from experience, the reason I have to say this is I know people don't want to do it. They don't want to do it the minute things get hard. But the minute things get hard is when it becomes the most necessary to do. So you want to practice it when things are easier. I know I keep saying that, but it's like physics is just a bunch of baby steps, but you got to divide it into a bunch of baby steps, and you got to be willing to do babies. You got to not feel like a baby when you do the baby steps. The genius involved in physics is being able to reduce things that look like garbage to a bunch of baby steps. So there's no shame in baby steps. So the steps here are, I wrote down the one thing I know, which is an equation, a definition for average velocity. But what I was solving for, what I'm asked to solve for, is x. So I algebraically rearrange average velocity and rewrite it as x equals v bar times t plus x naught, right? You see that? And notice that's a new equation now. It's a new, technically it still could be a triple equal sign maybe. It's a new equation. But please notice, I'm not asking you to memorize that. I'm not saying add that to your list of formulas in the back of your notebook or something. Like, because if you follow my method, you'll see every time we solve a problem, you'll develop a new equation. We're going to have equations all over the place, which is why physics can look like a big list that you have to memorize. But no, don't memorize them all. Realize you just derived from the one definition that we have, the one logic we have, we just manipulated and just derived a new result that happens to apply to this situation. What we're now saying is displacement equals average velocity times time plus original, excuse me, that's not what we're saying, I'm sorry. We're saying, well, we are saying displacement equals average velocity times time, which is a fancy way of saying distance equals rate times time, right? But specifically, we're then saying final position equals average velocity times time plus initial position. Right? That's what we're saying. So now we've got a result that should not be memorized, but should be used. We've got the unknown position, final position, phrased, expressed in terms of all the things that are known for this interval. Like we'll know V bar, we'll know T, we'll know X naught, we'll plug them in. But now, the reason I'm talking about this a lot is this is where a lot of people honestly did make a mistake. Very reasonable mistake. I'm not yelling at them. I'm yelling with them. It's like the point of the question. A lot of people now got confused as to what values to plug in for V bar, for T, for X naught. The most common misconception in the class or in both classes was that a lot of people for V bar plugged in like -9/8. Or something like that, or even like 2.4. They plugged in one of the values for V bar that we got earlier in the whole homework. Or they plugged in the value for the whole homework, for the entire 8 seconds. I totally understand why you would do that, but it is wrong, right? Part of the reason for the earlier exercises is showing us that averages change from segment to segment. So this whole motion was divided into 3 segments. For each segment, we had a constant, reliable value that for each segment, we were told the speed was a constant. So this is where we have to back up. Like it's saying, we're looking at the 7th second. We should take all our values from the segment, particular constant speed segment that includes that 7th second, right? In other words, and this is where we're going to reset our stopwatch. We're going to say, you know what? I'm not interested in the whole experiment now. As far as I'm concerned, I'm interested in that last segment of the experiment, the segment that includes t equals 7. So in my mind, I'm going to start my stopwatch at t equals 5, right? I'm going to start paying attention to t equals 5 and take measurements and values from there. Again, sidebar, really, this habit of like resetting and reestablishing the coordinate system and saying, wait, I choose x equals 0 to be over here, and I choose t equals 0 to be at this moment. The fact that we keep doing that, we keep resetting that we're both allowed to, but also we have to, is really what train of thought is meant to try to show you, but from another way. That when we talk about train of thought, I'm going to be trying to reinforce this whole idea. The idea is that the coordinate system, the reference frame, the perspective is not objective. It's up to us. So I'm just going to take values and look at that last segment of the whole thing. In effect, I'm going to reset t equals 5 to be my new t equals 0, right? So for this context, what's the average velocity? Well, we answered it in part, like, so I want to plug in values now. In part 2, question 6, we discovered that average velocity is -3 feet per second, right? For that last bit, because he's going across 9 feet to the left in a interval of 3 seconds. So the average velocity for that thing is -3 feet per second. And then I'm saying t equals 2. Why am I saying t equals 2? Because I've reset my stopwatch in my mind to start when t equals 5, right? I mean, this is confusing if it's confused. It is confusing until it's not confusing. I'm saying that what we used to call t equals 5, really now, in terms of plugging in this equation in this context, I'm going to plug in as 2 because oh, is that a hand? Oh, no, okay. I never know why. Anyway, and x naught for this is wherever the instructor was, like the value of x at this t equals 0. Like, where is the instructor at the beginning of this final segment? Well, by a happy coincidence, that happens to be +4, like the same place that he is for the beginning of the whole thing. So you don't, so I don't know if that makes it easier or harder, but that's the deal. So those are my values. So I plug in those values into the equation. I get x equals, in the units, I track the units cancel. Like I got feet per second times seconds. So the seconds cancel, and I get feet plus feet, feet plus feet equal feet. So I get -6 feet plus +4 feet. I get an answer of -2 feet. Like the answer is, where's the instructor at t equals 7? He is at the -2 foot mark, right? Now let's pause again. Everybody is all over, like, we're now in a class. Like, some of you are still like, yes, I know. And some of you are like, whoa, dude, I don't need, like, thanks for explaining, but I still don't even get what you're saying. I understand that. And that's why I really encourage, say whatever you want in the chat, say it directly. You can say, dude, seriously, this was obvious 25 minutes ago. You can say, say it politely and recognize that that may be true for you, but not other, or whatever. You could say in the chat, can you please go faster? Can you please finish the next one? Which I will, I promise. Or you could say in the chat, I'm still lost. I will not be offended either way, as long as you're not offensive about it. Because I do know that people are at different places with this at this point. I will tell you, this is the answer. X equals -2. The common error in not getting this right, like a lot of people just like left it blank or like panicked or whatever. A lot of people did something like what I just did, but they plugged in -9/8 instead of -3. So hopefully I've addressed that. A lot of people got it right, but their work doesn't look like mine. I understand that. Wait, cool. Wait for something in the chat. I actually think oh, well, thank you. Okay, someone just, well, that warms the cockles of my, all right, so for at least one person, maybe my explanation even helped. That's great. And of course, that makes me feel good and makes me feel like I'm not wasting your time. So I appreciate that. Okay, no, good. But I can still take I can handle negative. I mean, as long as we're anyway, whatever. Okay, good, thank you. But at this point, just so you know, in the last section, at this point, there was at least 2 people that were still like, wait, no, I don't. and they should not be ashamed of themselves. And we explain, so you're allowed to say, or you could even say in the chat, I still don't get it, but I just need to think. I don't want you to take time on it. I just need to think about it at home. That's totally fine too. That's like very honest. You can say that. I'm going to say, my goal, of course, is to finish the last one before the class ends, and I will. I want to say one more thing about this too. This is what I consider to be the optimum method of doing this. And I think I did do all the 5 steps for here, because now we're on a hard question. So hopefully I've shown you all 5 steps. I want you to see, yes, you could do it the non-optimum way, but again, you've heard me on this. If you've done it a different way, but you got it right, use it as an opportunity to practice this way before you actually need it. Like, you know what I'm saying? But also let me say, that last bit where I wrote x equals v bar t plus x naught. Well, I want to say 2 things about this, especially for you to do homework for. Like, notice that looks like a whole new piece of knowledge to some of you. It looks like I just pulled out something that's like unmotivated or unfair. It's like, oh, well, if I had had that equation, I could have done it. Right. But what I want you to get used to is you did have that equation. You just have to know right? Like, you have to have the calmness or whatever to trust whatever anything new that happens in physics somehow gets pulled out of the old. That's the good news and the bad news of physics. Nothing, almost nothing. Oh, good question. I saw a question in chat. Okay, I'm going to answer that. Oh, just finish this thought and then I'll answer that. But let me just say again, not even the homework 4, which is a bigger leap than this, and we will start going faster. Even everything there is still somehow coming from something before. There's nothing like, it should never be like, oh, well, I didn't watch the PowerPoint on the acceleration formula. Okay? So, and I will answer, I see the thing in the direct chat, but let me just say about this thing, I'm trying to show on the one hand, if you just want to be mathematical and you don't even know what you're doing at the beginning, but you just want to follow steps, you can get there by just following the procedure. But also, if you back up and just look intuitively, what that last thing is saying, it's just saying sorry, I'll answer the direct chat thing first, because I know. So someone's in the direct chat is very reasonably asking, where did I get 2 seconds? The most good question. Where I got 2 seconds was, we're being asked about t equals 7, but I think that the question is about the moment of t equals 7. Where are we? But what I think is that t equals 7 is 2 seconds into the very last segment of this whole experiment. Like, my secret insight for this whole thing is that each one of these segments had a different average velocity. Each one of them had an average velocity, but they were all different. So if we want to use average velocity to get displacement, which is what I'm doing here, we want to recognize, okay, we're in the last segment. We're in the t equals 7 is really the second of the last 3. Like the interval from t equals 5 to t equals 8. I'm zooming in on that in my mind, because from t equals 5 to t equals 8, we know, like the last 3 seconds of the whole thing, we know the instructor is going at a constant speed. We know any information we know about it at all applies to the whole thing. And we know what the average velocity for it is. We got it in part 2. We know the average velocity for the last 3 seconds is -3 feet per second. So what I'm saying, and I will pause to see if the person, I think this is a very important question. I'm sure someone has the guts to ask this. At least 3 other people didn't know it either. Maybe didn't even know they didn't know it. When I say 2, what I mean is I'm looking at t equals 5 to t equals 8. I'm looking at that last 3 seconds. And I'm saying, well, t equals 7 is 2 seconds into that. Like t equals 5 is like I'm counting as 0. T equals 6, I'm counting as 1. And t equals 7, I'm counting as 2, as t equals 2 in that segment. Please let me know if that, I'm going to try to say one other. So what I'm going to try to say one other way right now. I'm watching the clock, I promise. I won't hold you guys late. But I'm going to say one other way, and then I'm going to see if that person in the direct chat, if it worked at least for them or anybody. Because look, when I write x okay, cool. Okay, thank you. I appreciate that. So now, just this bottom thing, which to some people just looks like arbitrary. It's like, wait, he just made up a new equation. Okay, he did algebra, now he's a new equation, now he's plugging in. Okay, I guess it's math, and I didn't see. But step back and think of it as physics. What I'm really saying in the end there is I'm saying, you want to know where the guy is at the 7th second? What we're really asking is, where is the guy at the 2nd second of his last bit, right? So what we're really saying is, if we want to figure that out, what we got to know is, well, in the last bit, in the last bit, in that last 3 seconds, in that last 3 seconds, where he goes from +4 all the way to -9, right? And just zoom in your mind into that mini experiment. If you want to know where he is in the 2nd second of that, tell yourself, he starts at +4, that's the x0 bit, and then he travels at a rate of -3 feet per second for 2 seconds. What -3 just means he's going left. So it means every second he goes to the left by 3 feet. He does it for 2 seconds, right? So he starts at 4. So then from t = 5 to t = 6, he goes left by 3. So that brings him from +4 to +1. And then he does it for another second, because we're asking where is he at t = 7. So he does it for another second. He goes 3 more to the left. So he goes from +1 to -2. And that's where he lands. Like, it actually does make sense, and it should make sense at the end, no matter how you, okay, but that's my answer to the direct type person light. So we have 4 minutes left to finish the very last one. Luckily, I think the last one's, if you can do this one, I think it's like the hardest one in the sheet. The next one sort of follows from it. The next one, part 3, it asks, what's his average velocity from this like arbitrary middle segment from t = 3 to t = 7? Now, this is a very classic physics question. And I'm looking at the clock, I promise. This question is designed to like be intimidating, because if you've gotten when you got used to the fact that, like, okay, in the first 3 seconds, I know what his constant speed is. And then in the next 2 seconds, I know what the constant speed is. And then in the last 3 seconds, I know. Now it's asking you like this, like weird intermediary. It's asking you from t = 3 to t = 7. That's like it's in the middle of 2 different segments. So it's meant to look like, oh God, I don't know what to do there. But you just take it step by step. You like, that's the step 2, right? Step 2 is what, and the diagram is above. Okay, so the diagram above. So that's step 1. Okay, so step 2. So then you do step 3. All we know at this point is average velocity equals displacement over time. So you write it down. And then you're like, okay, displacement, the numerator is the difference between final position and initial position. The final position, what is the final position at t = 7, right? That's what final position means. The final position of this interval we're looking at, this mini experiment from 3 o'clock to 7 o'clock, we need to know where he is at 7 o'clock. Now, that would be an impossibly annoying question, especially to answer in the middle of all this, except that we just answered it, right? Like, we need to know x at t = 7, where we just went through all this work to figure that out. The answer is x = -2 feet. Then we need to know, well, at t = 3, we need to know where he is then, right? Because I'm figuring final position and initial position. Where is he at t = 3? What's the initial position? Well, that I wouldn't know either. That would be impossible, except if you turn the pages back of the original problem. It tells you in the problem that in the first 3 seconds of all of this Michigas, he goes from position +4 to position -2. It just tells you that in the problem. So the initial position for this interval is x0 = -2. Funny coincidence. It turns out for this intermediary journey, we know where he started, we know where he ends. It happens to be the exact same place. So we put it all over 4. It turns out, once again, this guy took 4 seconds to go nowhere, to get displaced nowhere. He might have had a very high average speed for that, but it was a round trip. He started at -2, he ended up at -2, so his displacement was 0, so his average velocity is 0, and that's the answer to the end of the sheet. And that's the sheet. We will go faster and faster. Well, I mean, we will make more and more tracks. You won't be assigned another homework until I start dealing with homework 4. So you have a break. You've been very patient, but hopefully you see we're trying to lay down the fundamentals of how the whole thing is. What do you do when you don't know what to do? The only place to practice that and to figure that out is to practice what to do when you don't know what to do by looking at what you do when you do know what to do and spelling it out for yourself. So this is how. So you've been very patient. Obviously, the homework for Wednesday is try your best on average acceleration homework 4. I'm done. I'm going to hang out for any questions or any issues. But have a great 2 days, and I'll see you in 2 days. And I'll be in my office tomorrow if you want to come by. Bye. Thank you. Awesome. Bye. And I'm going to turn off the recording. Have a great day. Thank you. Thank you. Awesome. Yes. Bye. Thank you. Bye. I'm turning off the recording just in case. Bye.
Thank you. Have a good day.
Thank you. You too, Melina. Thank you. Awesome. And thank you. Thank you. Oh, thank you. Okay.
Bye, Professor. Thank you.
Thank you very much. Thank you. Awesome. Okay.
Hello, Professor.
Hi. Wait, I do want to stop the recording before you get recorded. Hold on.